Yes, the next topic is this is P. Ganesh. Today we are going to see the resistance split phase induction motor, right? Resistance split phase induction motor. So this is a single phase induction motor. It is a type of single phase induction motor, and now going to see the resistance split phase induction motor, right? And see here. So this is, as we discussed earlier, or the previous video, so which explains the first video which explains the principle of operation of single phase induction motor and why it is not self-starting induction motor, right? And the second video which explains the why it is not a self-starting motor and what are the classification of single phase induction motors, and what is the whenever the two-phase supply is connecting across the single phase winding, then the rotating magnetic field is producing, how it is helpful to start the single phase induction motor, as we discussed in the second video, right? So the third video which going to explaining the resistance split phase induction motor, and here is the resistance split phase induction motor. So what is the first, we go for the construction features of the resistance split phase induction motor. Now see here, so this is the construction features of the resistance split phase induction motor, and here there is a V. V is nothing but is the voltage applying or the connecting across the two terminals of the single phase induction motor of stator part, right? And this stator part and due to this the current input I, capital I, which represents the input current I, and the middle part here, the circle part, which represents the rotor of the single phase induction motor, and this rotor is always the squirrel cage type, because of the reason the ends of the conductors is always the shorted, and the available of rotors is always only one type, which is called as a squirrel cage type. As we discussed in the case of three-phase induction motor, depends upon the construction of rotor. The three-phase induction motors are classified into two types. One is called as a slip ring induction motor, another one is called as a squirrel cage type of induction motor. But here is the stator winding is different. So in the case of three-phase induction motor, so that is the single phase induction motor having the only stator part, which is splitting into two, so that it is classified into four types. One is called as a resistance split phase induction motor, and other one is called as a capacitor start induction motor, and the third one is called as a capacitor start, capacitor run induction motor, and fourth one is called as a split pole or shaded pole induction motor. Now here, what is the main construction here? So here the winding, so the starting winding here is, this one is called as a starting winding, right? And this starting winding is specially designed with the high resistance value and the low inductance value, and it is connecting with the centrifugal switch CS, which represents the centrifugal switch, and here is it. So the current carried by this winding, which is called as a starting current IS, right? And whereas here this is the main winding, so the main winding specially designed with the high number of turns, which offers a high inductance and low resistance value, right? And here the IM which called as a main current, so which carried by the main winding, These two windings are connecting in perpendicular to each other physically, right? And here see, we'll see the paragraph of the resistance split phase induction motor. So it is a very simple design of a single phase induction motor, right? And here see, the stator winding is divided electrically into two parts, and one part is known as a starting winding, and or it may be called as an auxiliary winding, or it may be called as a temporary winding. Other winding is known as the main winding or the running winding, or nothing but as a permanent winding, right? The starting winding is intentionally designed to high resistance value. The starting winding is intentionally designed with high resistance value, and therefore a thin wire is preferred. It has less number of turns. In case of starting winding, the number of turns is very less, already we discussed, and less inductance value, right? The main winding contains large number of turns naturally and designed for low resistance due to resistive nature of starting winding, right? So the current flowing through it is nearly in phase with the supply voltage in case of the starting winding. Because of the reason, the starting winding is having high resistance value. In case of resistor, phase differences between the voltage and current is always the zero, right? And here the current in the main winding lags this with the supply voltage consequently. Because of the reason, we already know the main winding is always having the high inductance property, and it always the lagging. The current in case of inductance is always a lagging, but in case of capacitor it is always leading, right? But in case of resistor it is always in phase with the voltage. So there is an angle alpha between two currents which produce starting torque. And here is the most important point, that is called as a two currents which produce the means phase differences between the currents Im and the Is, right? And here just simply observe phasor diagram, so that it is very easy to get understand by observing the phasor diagram. Now see here the line V, the V line which represents the supply voltage, and here is the Is, that is a starting current Is. So here how the Is and Im is getting, right? And the total current here is the input current, which is splitting into two parts. One is called as Is and other one is called as Im. Because of the reason, here we get one junction at here. So due to that junction, what happened? The total current is splitting into two currents, which is flowing Is, starting current flowing through the starting winding, and the main winding, main current flowing through the main winding, right? And here the centrifugal switch is activated whenever the rotor speed gets to 70% of its rated speed. Then what happens? The centrifugal switch is automatically activated and it is disconnected from the main winding, so that it is called as a starting winding. And under the running condition, the main winding is always, or it may be under the running condition, the main winding is always produce the rotating magnetic field in the air gap, so that it is called as a main winding, or it may be called as a running winding, right? Here see the phasor diagram which explains the principle of operation of resistance split phase induction motor. Now see what happens. See, so whenever the starting current which is lagging with respect to the supply voltage line. So why the starting current line which is lagging with respect to the supply voltage line? Because of the reason, the starting winding is also having a small number of turns. So this number of turns which means develops which offers the inductance property, right? So due to that inductance, smaller inductance offered in the starting winding, then what happened? The starting current Is line is always lagging very slightly with respect to the supply voltage line, right? And other one is called as main current line. So this main current line, it is always larger phase differences between the supply voltage and the main current line. Because of the reason, the inductance, the number of turns present in the main winding is very greater, so which offers a very greater value of inductance value, so that what happened, the main winding, the main current is always lagging with a greater value of phase differences, the greater value of the phase difference with respect to the voltage V. And here is, once observe what happens. See here, there is a phase difference is offered between the two currents. One is called as the Is and the Im, right? And this is the here is the important thing which is develops the resultant flux develops due to these two current which is rotating with the speed of synchronous ns, which is rotating with the speed of synchronous speed, right? And So what happened, see, so the resultant flux, which is always rotating with the speed of synchronous, and that rotating magnetic field which links with the rotor conductors, and what happened, an unidirectional torque is producing in the rotor conductor. At starting time the rotor is rotating easily, right? Now here, see, the torque producing in the air gap, the torque produced in the rotor conductors is always proportional to the Im into Is into sine alpha. Im into Is into sine alpha. And this torque value, which is always depends upon the alpha value. What is actually this alpha? This is the phase angle or the phase difference between the starting current and the main current, and this is alpha. In case of resistance split phase induction motor, this alpha value is approximately 25 degrees to the 30 degrees, depends upon the induction motor, right? And here this 30 degrees value which gives very less magnitude. So sine 30 degrees which gives a very lesser value, and the lesser value which multiplying the Im into Is, so that the torque develops in the rotor conductor is also very lesser value, right? So these are basic disadvantages of resistance split phase induction motor, right? And see here. So due to this reason only, we go for the next induction motor, which is called as the capacitor start single phase induction motor. And here is the whenever the rotor speed gets to 70% of its rated speed, then what happens? Centrifugal switch is automatically gets operate, and it means that it is opened and it is disconnected, so that it is this winding which is called as a starting winding, right? So under the running condition, the main winding is always working, and which produce the rotating magnetic field, and here, so now see, so this is the most popular for motoring motor rating around 500 watts. So it has a low starting torque, because of the reason the starting torque which depends upon the alpha value, and that alpha value is always 25 degrees to the 30 degrees only, so that it is not suitable for the frequently starting and stopping, right? Because of the current flowing in this, because of the reason alpha. And moreover, the starting winding current is always very greater because of the very lesser value of the alpha. So due to this reason, what happened, the starting current is very greater, and very greater temperature is also means developed in the starting winding. Due to that reason, what happened, immediately there is a chance to get damage of starting winding, and due to that reason, what happened, it is very disadvantageous. And it has low operating power factor also. The operating power factor is also very low under the running condition. So there is a centrifugal switch which gets open when the motor reaches over 70% of its rated speed. Consequently, starting winding gets isolated and motor run with main winding only. As we already discussed, that is called as a very simple. So due to this reason, so the disadvantages of the these, where we go for the capacitor start single phase induction motor, right? And so, and moreover, the alpha, it is here, it is a very lesser value. But in case of capacitor, by adding the capacitors in series with the starting winding, then what happened, there is a chance to increasing the phase difference between the main current and the starting current, that is a alpha, right? So that we go for the capacitor start induction motor. And once see, just brief discussing regarding this capacitor start construction feature. In the next video, we'll see complete details of the capacitor start induction motor, right? And this here is the one capacitor value. Here is this one, right? See here. So here is capacitor which is connecting in series with the starting winding, and this capacitor values are always very larger value, so that this complete part which is acting like as a capacitor only, right? And here also the capacitor is working under the starting time only. So under the running condition, whenever the rotor reaches to the 70% of its rated speed, then what happens? The centrifugal switch gets activated and it is opened. At starting time it is always closed, but at a running condition, whenever it reaches to the 70% of its rated speed, then what happens? The centrifugal switch gets to activated and it is disconnecting from the main winding, right? And see here, due to the adding capacitors in series with the starting one, then what happened? The starting current, it is always leading with respect to the supply voltage. With respect to the supply voltage, then what happened? Immediately the phase difference is improved a very large, improved a very greater value, that is up to the 80 degrees. So due to this reason, what happened? Immediately then a very better torque is producing in the air gap. Because of the reason, here see, the torque is always which depends upon the Im into Is into sine alpha. So sine alpha means that is 80 degrees, so it gives a very better value which is multiplied with the Im into Is, which gives the best torque in the rotor conductors. So in the next class, we'll see the capacitor start induction motor, right? Thank you. So that is in the fourth video we'll see the capacitor start single phase induction motor.